Hi. Today we'll try to continue with our application layer module, and we get to the part 4. We're going to be talking about the email, how the whole system works, how many different protocols we have, and how kind of complex the system is. So that's why I kind of put in the title. So email, it's not so simple protocol, or actually a set of the protocols. To give you some basic idea what how the whole system actually operating, we can kind of just think of 4 major components of the system. So one of them is so-called this very simple things are mail agents. So this is either your Gmail application or a standalone application that you can install, like Apple Mail, Outlook, or some open source things like a Thunderbird or many other things. So the important component of the system is mail server. So the mail server is something that runs on the back end and actually delivers your mail. And kind of with respect to the Gmail, what you think maybe what the mail server is, it's actually running somewhere on the back end of the Gmail system that you don't really interact directly, but rather whenever you send messages or somebody sends messages to you, so those things actually getting through the mail servers. And we'll try to highlight a few things when I'm going to do them a little bit later, how many different servers actually in existence in Gmail. Finally, so those were 2 application parts. So there's a user effectively acting as a client, there's a server that acting as the actual server. And there's at least 2 types of the protocol. So one protocol is SMTP, or Simple Mail Transfer Protocol, and we'll talk quite extensively about it. So this protocol is for delivery of messages. So kind of pay attention to that one. And the second part of the protocol is for the retrieval. So for the retrieval, we have traditionally we have a few protocols like IMAP and POP3 exchange, if you're talking about Microsoft Outlook. But primarily today, at least I'm sure most of you are simply using Gmail, which effectively using HTTP as a protocol to access your mailbox, and whatever happens in the backend is just a Gmail's business. They probably use some form of modified IMAP protocol, but it's technically not really known to the public what exactly they're doing. The process of sending email is actually not that trivial, as I tried to hint at already. So whenever you try to send a single email to somebody, there's actually at the very least 6 steps for this email to be delivered to the other person. So first of all, you have to write the message. You have to put this message to the mail server, or kind of to put in the queue or in this mail server. So this, even with Gmail, this happens somewhere behind the scenes. So after that, the mail server, like after you put it on the queue, creating TCP, first of all, it discovers what is the mail server responsible for the other side, and then establishes TCP connection to one of the mail servers that are responsible for that mail service for that domain name, and sending a message over this TCP connection. And finally, to retrieve the this email, Bob needs to contact his email provider directly, or either going to the Gmail servers or running the program to run this IMAP or POP3 protocol, and finally do whatever these protocols are required to actually fetch the message. So the process is effectively multi-step, and there's good reasons for this multiple stages. Sometimes it's creating a problem, and I'll try to highlight a few problems a little bit later. On this slide is just the same process, but a little bit in more formal way, representing which specific protocols are commonly used, or like which protocols are being used. So for example, for the sender part, it's kind of not the exact protocols are not defined, because it's some application running. It's either on your computer or just your Gmail. Then the process for delivery uses this magical SMTP protocol. It's either between your agent to whatever next SMTP server. There can be multiple stages of delivering the email from one SMTP server to another SMTP server. And to highlight one possibility, there is some kind of virus checking. This can happen within the single server, or it can kind of pass it to kind of some secondary server to deliver this kind of some antivirus, some additional checks, checking for spam, and so forth. So your message effectively can transfer multiple times between different servers before reaching the mail servers of your domain name, or Gmail service, or FIU service, for example. And even within the whole system, like inside the Gmail, your email can again transfer multiple times before it being delivered to so-called the mailbox. And again, what this mailbox is depends on specific deployment scenario, and effectively just to allow you to retrieve this email by whatever protocol is defined. I mean, commonly used is IMAP. It used to be popular POP3 protocol, or also popular protocol is Exchange if you run in Microsoft Exchange and using Outlooks. Now, I just want to highlight a few critical elements of the protocol itself, and just to highlight the protocol and how it operates. So within the protocol, first of all, you have to establish this TCP connection to the server. Then there's some form of, inside the protocol, there's additional handshaking involved. Why exactly it's doing, I'm not 100% sure, but at the very least, you're trying to discover capabilities of the other side, so you can kind of negotiate what kind of things you want with the mail server, or what you can do with the mail server. Then there's a transfer of messages, and finally you closing the connection, kind of closing the application connection and closing actual TCP connection. There's additional step that highlighted in parentheses here is a secure session. So this one kind of commonly, right now it's very commonly used to start the SSL connection in order to prevent others to see that whatever you're sending, what kind of messages you're sending, but it was not from the beginning of the SMTP protocol. But essentially just doing something similar what HTTPS is doing. You establish the TCP connection. Over this TCP connection, you're kind of requesting some form of security credentials, and every exchange afterwards is being completely encrypted and private between you and the server. It doesn't mean the whole email system becomes suddenly secure. It's just the connection between you and the first mail server is secure at this point. The interesting part of the protocol is the fact that everything is actually in ASCII text. So all the headers, all the messages, all the actual messages inside the protocol is being sent out as a ASCII readable. One thing that would be very, very familiar to you is all headers and the formatting of the messages themselves are pretty much follow HTTP. Like there's a headers, there's a kind of empty line to separate, there's a body, and there's some kind of indication of the end. So this part is a little bit different from HTTP, where we had two different ways of ending the HTTP message, and that would be first question for you to answer during the lecture. In SMTP, we have a special way of indicating this, but I'll just highlight. The interesting question, I mean, not the question, but the comment here. So even though the protocol itself, like all the information that has to be transferred within the protocol is the 7-bit ASCII, like human readable or actually readable characters, you can actually send everything. And I mean, we normally send files, we normally send pictures and whatever we want. And I mean, you can ask me immediately how the heck this can happen. But it's very simple. There is a special encoding called the base64, and using this encoding, you can convert any binary to like subset of ASCII characters that kind of readable, that can comply with this format, and everything is fine. And computers can easily convert from normal binary to base64, and from base64 to normal binary. So there's no any kind of the problems. And to give you an idea how exactly this SMTP protocol works, it's really, really simple protocol. And I actually will try to do it by hand in a few seconds. But to give you an idea, kind of all the stages. First, you're trying to establish the TCP connection to a specific mail server. So this one, I just picked a server from UCLA. After you connect it, the server will give you some header or some initial message. It may or may not give you actually this information, and then expecting you to give some handshaking input. After that, you can start sending, initiate the handshake, and there's two ways of doing this handshake. One is hello with one L, and the other one, like the more modern way of doing this handshake, is for some reason hello, like they just switch the E and the H. This is more advanced version. I'm not 100% sure why they decided to give a different name for basically the same handshake. And what the result of this hello or like a handshaking is give you effectively what kind of capability this mail server provides, like what kind of the maximum size of the message that you can send, whether it supports pipelining, not supports pipelining, and in the same way HTTP 1.1 is doing this, and a few other things, kind of whether it supports SSL and so forth. So finally, the next step is to define message itself, and so this process actually is a little bit complicated in the sense that you have to, within SMTP, specify where you want to send, to whom you want, where you want to send, from whom you're sending, and if required, you have to do the authentication. So some SMTP servers require that you authenticate before you send anything. So for example, Gmail would be one of such cases. And most of the mail servers, so-called relay mail servers, require authentication in order to send message to to anywhere outside this mail server. So they can normally, and the same, because the same protocol is used to deliver message at every stages. So the last stage, you don't, like, to the final mail server that actually serves your domain name effectively, you don't need to do any kind of authentication because that's impossible to do. But the first stage, like when you connect into your provider's SMTP server, or connect into Gmail's SMTP server, and you want to send somewhere like in FIU, you have to do the authentication. I'm not showing this, but there are tons of examples of online if you really want to try to do it by hand. And as I said, you have to indicate from where you're sending this message, and if everything's fine, you'll see something like 250 is in OK code. And finally, kind of the final stage is to actually add the message. And to start the message, you have to type this data. So that's an additional command inside SMTP. And the rest is basically this HTML protocol. So there's a few headers and key value pairs like for the headers. So one of them is subject. Another one is to. Can be from. So note, I'm kind of duplicating what I already mentioned, but the previous ones were SMTP commands, like what you actually want to do with the message versus the message itself. They don't necessarily have to correspond to each other. So this is semi-vulnerability of SMTP protocol. So I don't know whether you're receiving various emails on the mailing lists. So if you open source of that message, you not necessarily see that it kind of in the message itself it was destined to you, so there is no header to you, but you still got this message. So that's kind of this discrepancy between what the SMTP operation is and the actual message of SMTP. So you can specify whatever you want here, so like subject, to, and additional headers. There can be tons of different headers that you would like to include. Finally, you have to separate with one blank line between headers and the body of the message. Then you just complete the whole body of the message. In this case, I just did very simple text. And as SMTP server suggested, you have to have an empty line, a period, empty line, to indicate that this is the end of the transmission or end of this message. After that, the mail server accepted this message for the transmission and everything was fine. Let me give you one small demo where I just try to connect to our departmental mail server, port 25. So port 25 is the default port for SMTP. There are two more ports that effectively just used for secure connection, but they behave in exactly the same way. So the first thing, I'll just try to introduce myself, csfiu.edu. This simple for effective for discovering the capability of the server. Technically, you can introduce any kind of the domain or say anything you would like is that part. So the second next step, I'm just input a few SMTP headers to identify myself as who is sending. So mail from aacsfiu.edu, it accepted, and finally I can just include as a recipient oops, I made a mistake. And hopefully this time it was accepted. So mail got accepted. Now I can start actually typing the message. And I'll try to subject, hello world, again, I can type, just in case I'll type a completely different thing from this header, just to highlight that this is possible to do. What else? Some X header, foobar. So this is just additional header that I decided to add. It will not be shown as in the message, but it will be part of the message itself. And finally, empty line and hello world as the first line of the message. And to separate, as we were given, we have to put the period and end of the message. So effectively, just the empty line, period, and empty line, or kind of carrier break, period, and carrier CR and LF. That's it. And as a final stage, we can say nicely that we exit in the SMTP session and be done with the transmission. So that's effectively it for the demo. To demonstrate that I actually received the message, I already prepared a few things here. Let me check. I hope it will be received. Let me check. Oh, yeah. So finally, I got the message. This is the message I just sent. As you can see, there is a subject, hello world, there is something inside the body, and there is a secret function in Gmail and all other mail clients. You can actually open the original, and this original will tell you everything about the message. I'll go in a few seconds in the detail of the message, but just to highlight that all headers that I have sent, I have included manually, are still there, plus there's a few more added as part of the actual exchange. So this is what I have entered from, I did enter this part, X header, I did enter this part, to subject, and there's a bunch of other headers that were added automatically. And the interesting part, they were added by different parts, by different servers while they're transmitting your message. This slide basically demonstrates everything that I was just showing manually, just splitting the process into smaller pieces. And I honestly recommend you to try to play with the SMTP protocol manually. You can use either SMTP csfiu.edu if you're on campus, but you can also use smtp@gmail.com, but you also need to do authentication because Gmail will prevent you to do anything unless you authenticate. You can find the kind of specific authentication, how to do it, there's tons of resources online. Just Google it. Again, I already highlighted the whole protocol, the whole SMTP protocol is very, very much similar to HTTP. I mean, you saw the SMTP message itself is a header, blank line, the body. The protocol, again, not exactly GET, not exactly, there's completely different commands, but also there's some similarities. The other part of similarities is these error codes. They're basically the same format. Everything that starts with 2 is something positive, and the rest of there are 3 digits. There's additional indication of what could have happened. So, for example, 220 means everything is fine, and 2201 something also fine, but there's additional clarification. Maybe there will be additional message attached. And anything else, not 200, something like 500 messages is something bad. Like really, really bad with the servers, or something not authorized, or something, some other error code. I think I already highlighted most of these things, so you can just for you to remember for later. Few comparisons or few differences between SMTP and HTTP. So the main difference is the way we operate with the protocol. So with SMTP, with HTTP, it always we go connect somewhere and we request some data. And there's also the mode of HTTP where we push in data, but it's still in the way we kind of interacting. We know URL, and we're requesting to push. So kind of we operating from that mode. So it's kind of still client-based operation. With SMTP, you always do some form of a push. So there is no preset client. So maybe it exists at the initial stage when I create the message and I'm pushing it to initial SMTP server. But then the process actually repeats itself multiple times and the message being pushed further and further towards the destination mailbox. So that's interesting part of the SMTP protocol. Everything is similar to HTTP, HTTP 1 and HTTP 1.1. Everything is still within a binary in ASCII encoding. And actually it's a 7-bit ASCII encoding because you cannot even use the whole range of the characters. This is slightly different from a modern HTTP protocols like HTTP 2 and QUICs. One interesting difference, but it's kind of the conclusion or the result of the push versus pull. In HTTP, we have ability to name individual objects. So for example, we have an image, we have a URL for the image. If we have a HTML page or JavaScript file, we have individual names for those things. In SMTP, there is no such thing. SMTP, it's a message. So that the unit that we're transferring is the message. And if we need to include multiple things, like for example, if we want to include the image in the message, it's a little bit of pickle to do. So one way, of course, and that's some of the mail clients actually trying to do, is to include the URL of something that exists externally. But the problem of this, it's you have to put it somewhere externally. So like, for example, if you have a Dropbox, you can include the Dropbox link into your mail and everything will be fine. But that's kind of not native to SMTP. There is a possibility to include more information inside SMTP instead of just the plain text. And for that, the protocol designers invented the concept multi-part email message. And inside the multi-part message, there's actually multiple things inside the body, and the mail client actually interprets the whole thing in a proper way, extracts individual pieces, and then trying to link them together if they're properly linked. Like in simplest case, if it's just attachments, so it just interprets, visualizes the text part and kind of highlights, oh, there's several attachments that you can download. Or in some cases, there's alternative HTML text, alternative plain text, and depending on which client you kind of interprets this information, it can visualize either one or the other part. Or if you're using kind of HTML with embedded images, kind of those images still have to be part inside of HTML message. So this is effectively what I was trying to highlight, how to include kind of something beyond just basic plain text. So you can, instead of just writing the actual text of the message, you can actually put encoded base64 data. But if you do so, you actually have to indicate a few things as part of the header. This is actually an interesting example highlighting that this message, the whole message here, is just image. So you can do that. It's maybe not ideal for from the perspective of the mail client, because that would be just one image received. There is no kind of additional text associated, but it's possible. What I'm not showing here, what you can have is multiple these things included as part of the message. So this is what I was just talking about, the multi-part message, where individual parts will start with a header, with its own header, like it look like exactly this content transfer, content type, and maybe a few additional things depending on what you're including. Then the actual data, and then separator, then another header, another data, another header, another data, and so forth and so on. So you can play with the different things, and I'll try to show maybe some other messages that I have in my mailbox to highlight those things. Okay, let me try to look at the other message that I had. Okay, so this is the message I have. See, there's even some kind of picture. Let me try to open the source code of this message, which will highlight there's tons of different headers. So as you can see, this message is quite big. What I wanted to show is a few things, kind of the border of the message. So as you can see, there's tons of different headers like included here, and we finally got to the body of the message. So there is a concept. So the concept of this multi-part message is that there are kind of, you define the separator and then start with header and then data. So this one is actually starting with the kind of this is completely random number that exists in the message, just to make sure that this sequence doesn't really appear anywhere in the message below. So it's going to act as an actual separator. Then the header, then the kind of separator from the header to the body. The body of the message, I guess this one is in a plain text format. And I suspect there will be the second part. Yes, so there's a second part in HTML. This is not exactly base 64 encoding, but there's a so-called coded printable format of the encoding. It's just a special way to encode some special characters, but still preserve most of the printable text. So as you can see, there's a bunch of information, and in this case somehow there is no picture. I guess that picture was included as part of the just URL to some external website, but I hope you got the idea. So there's a message, message contains the body, and if you're using this Multipart extension and your client supports that extension, most of them actually support, then everything is fine, and you can kind of include multiple things inside the same message. So I already highlighted a few things. So this is exactly the same examples that I was showing. It's just highlighting of what have happened in different places. So another thing, from the source, so the source code of the message that you have received can reveal you a few different things, few interesting things actually. So one of them, you can kind of trace of where this message was originated, how many servers it passed through, like where it had been, like where it was hauled off, how fast it was received. Again, most of this information is completely voluntarily added by the servers, so they're kind of nice enough to include this information. But even with this nice enough servers, we can infer quite a bit of information from the headers. So for example, the message that I was playing with before, and I included on the slide, had something like this. So it indicated that it was received from some IP address, and this happened to be in Berlin, because I was sending at that point from the Berlin server through my CS UCLA account, and it was saying, oh, it was received by this guy for this guy. Then there's another message received, the same message received by the internal service inside, and I'm guessing this is some form of either spam checking or some antivirus checking, or of some kind of like this. Then there's additional kind of iteration inside the server that again did something. I don't know exactly what exactly happened, but there is some internal processing. Then finally the message got delivered to some other server, again inside the UCLA service. It's still getting internal processing, but this time I'm guessing it's outside this antivirus processing, and again, it went to yet another mailbox, yet processed, and so forth and so on. And if you open any of the messages, in all the clutter that exists in there, you will find a bunch of those received from headers. And so this one, the last three, at least a few years back, indicated that message went to a Gmail server. So it received by the front-end SMTP server, then it went to yet another SMTP server inside the Google network, I guess for some kind of a load balancing, and then yet to another one, and that hopefully it was the final destination for that message. Again, I recommend you just go to your Gmail and kind of look at the source code for any of the messages, and just to try to infer what happened to those messages, because it's kind of interesting to know how many servers actually looked at the message. And this is fact to highlight, like my objective here is to highlight the problem, and the problem is, even though like the first step or like second step or whatever steps is secure or completely private, like for example between myself and the first SMTP server that I am communicating, I'm like encrypting this, like everything is encrypted, very high level encryption. That mail server is reading my message because that was the end of my security. Then all the individual guys on the path, be it antivirus, additional antivirus, some load balancer server, will see your message. And they will, because this is how SMTP protocol works. It needs to know all the headers, and consequently it also sees the body of the message. And the message goes on and goes on. So be aware of this interesting issue. So this just highlights how many different providers we can use. As I said, if you're at home, you can easily use your there's SMTP servers in Comcast, AT&T, and all other providers. If you're using Gmail, you can easily use SMTP service from the Gmail. It has some limitations from the security perspective, and it requires you to authenticate with your Gmail in order to send anything before you send something. Other service, and I just showed you with the FIU, CS-FIU service, if you're inside the network, you can actually start sending without doing authentication. But again, this only works inside the network. If you try to follow my steps when you're at home, not on campus, and actually not inside CS network, then it most likely will fail. If you want to play with SMTP manually using Gmail, so you can use this command on your Google Cloud VM or any other Linux machine or macOS machine or Windows machine if you have OpenSSL. So you can use this command and try and follow the steps. Instead of username and password, you can use your username, like your email address, and for the password, your password, and then follow the rest of the steps. Because you're establishing this secure connection, don't worry, nobody will see your password except like if somebody looking at your screen, and you will be able to do a lot of things inside this SMTP protocol. As already highlighted, securing the connection to just the first hop, like the first SMTP server, doesn't really make the SMTP service or mail service secure. And the word secure here is actually a little bit overloaded because it can mean different things. So one of them is nobody's looking at the email that you're sending. So that's kind of not the case. Nobody in transit can see your email, but the mail servers themselves can see the email, and any intermediate mail server also will be able to see your email. The other part of the security is actually whether someone is authorized to send you email. That's actually an unsolvable problem. And whether someone is authorized to send from this email address. And the last problem is kind of solved in certain contexts, but it's still relatively easy to forge email that pretend to be sent out from somebody else. I don't want to recommend you to do that. This is kind of not nice, but it's usually the most fun part. If you run the SMTP protocol manually, you can always specify something different as part of the mail from, or like even from field when you're typing the actual body of the message. So you can type basically anything, and if your mail server will accept this message, so that part if you're playing with the Gmail service, this may not happen. But if you're playing with any other SMTP service, then you may be able to actually put any garbage as part of or any interesting part as part of the receipt mail from and from addresses as well. But as I said, this from part is being actively solved. The problem is still, even though you still can forge information, there is several levels of verification that this email, that someone who sent this email was using the proper kind of origin mail server in order to send it. So, for example, if I'm using my aa.cs.fiu email address, I don't have to technically use the FIU mail service. I can use the Gmail service, but then it will not process one of these additional security layers. So if someone on the recipient side doing very rigorous checks, then I'm potentially a little bit out of luck to deliver my email in that case. So then I will have to fall back and use my SMTP CSFIU edu server that will authenticate me and then include this additional headers as part of the email. And SPF, I mean, they both work for the kind of the same purpose. It's just a slightly different policies indicating like verification of the domain or verification of the actual sender host. One thing that I have implied as part of the security is the fact that mail was sent by me. As I said, you can technically, if you use some third-party services, you can still technically forge email that is pretend to be sent out from me. So, for example, if you want to some additional extra credit point for this lecture, try to send me email from me, if you understand what I'm talking about. But there is a mechanism, like signature mechanism, cryptographic signature, and there's several different ones, to ensure that this email was indeed sent from me. Like you can actually verify and ensure that that was the fact. Another part is encryption. So if you want to make sure that your email, and actually only the body of the email, is not seen by anybody, and by anybody I mean not a single intermediary server can see the content of that message, then you have to do encryption. But the way the email system is designed for this, in order to do encryption, you have to get the public key of the guy you're communicating with. So there's not that trivial process, and you have to keep the private key associated with whatever you're encrypting kind of alive, so you can decrypt it. You can decrypt the message being sent to you. So it's a non-trivial process, and not many people are using it. All messages that I've been sending before are not really authenticated, with one exception. So the messages that we exchange inside a canvas, so those are basically secure. And those messages are really not using SMTP protocol. They're not actually leaving the canvas anywhere. So the canvas effectively ensures that messages I'm sending there are from me and to you, or from you to me. So it's kind of even more secure than the messages that I'm kind of effectively sending you over the email. There are two ways you can play with securing your email. So one of them, you can get a certificate for your email from a certification authority. So this one is similar to getting a certificate for the website, but instead of the domain name for the website, you would get a certificate for the email address. And you can Google those. Most of them want some amount of money for that, but I think there's one that gives you a certificate for a year for your email address. The other one that is a little bit more popular in certain areas, but still not being actively used too much, it's a Web of Trust using PGP, or PGP is a pretty good privacy protocol, and GPG is a GNU implementation of this protocol. So it's PGP and GPG, interesting name. So if you want to play with this one, there's things that you can download on all operating systems. So there's for the macOS, there's GPG tools, or you can install for using Homebrew. For Windows, there's one, and for Linux, there's tons of built-in packages that already either pre-installed on the VM, or you can quickly install. And to highlight the macOS version of this, there's just nice GUI tool. I think for Linux, there's exactly a very similar GUI tool. This just highlights that I have collected over some small email exchanges that I had, some number of public keys of the guys. So now this is effectively my local database of the guys whom I trust to the various degrees. And you can see on the column here, there's indication of the trust to this specific public key. So some of them are marked as red, meaning so this key either not valid at this point or already expired or something bad happened to the keys. So it's kind of they known to be bad. There are green keys, like green indications saying, oh, so this key is still valid, or I have put a special trust for this key like manually. So I actually did some of this manually. And the yellow ones, these are just the ones that I have added to the database, and I didn't put any indication whether I specifically trust them, but they also not expired, and as long as there's no conflict, they're kind of considered as a okay keys for the purpose of some kind of verification or encryption of the messages using these specific keys. And if you're using Gmail, then actually you're pretty much out of luck for using encryption, except you can do some form of a manual encryption and then copy paste as part of like, the actual body of the message, so others can manually extract that portion and do the decryption. So this is not a very nice way of operating. If you're using something like Thunderbird, Outlook, or Mail app with the additional plugin, you can do this PGP encryption and signing, and there's actually built-in ways to indicate whether you want to sign the message, whether you want to encrypt the message if you can encrypt. So for the encryption, you still have to know the public key of the guy, and initially, normally how it happens, you exchange the signed emails first, and then after that you can start sending encrypted messages. If you want to play, so this is a system, I'm not advertising of any kind, but this is a nice system that they created. So there's a keybase.io. So effectively it's some form of kind of online database that can store your PGP key, and kind of from different operating systems for different computers, you can log in there and do some form of PGP encryption. And as incentive for you to try this, they actually gave out a few, okay, not bitcoins, but they invented their own coin system. And literally a few days ago, they gave me, I think, equivalent of $23 of some kind of a coin. So if you sign up today, they promise to give more coins in the future. So if you sign up, you may get some kind of digital coins. I don't know how to use them or for what purpose or how to convert to actual currency, but you can try. If you want to play with the PGP signing or even playing with the keybase, so with the keybase, you just simply select, oh, I want to generate this public key, I want to add this key or something, or generate this private key, and most of the things will happen almost automatically. If you like command line, and I hope by the end of this class you would love command line a lot, you can try to do something signing manually. So for example, this gives you a few commands how to sign. You simply need to do this GPG clear sign, then copy paste of what you want to sign, or just literally type it. And the end of the input with the Control D. If you do it in command line, Control D is the common way of ending the input. And then the output will be some indication that it was signed. So it has a few kind of header of the message and then some information outside. So as you can see, because you do signing, not encryption, you still include the plain text of the actual message. You just indicate what is the beginning, what is the end of the message, and there is some information about the content of this message, like how the actual encrypted stuff. And as you may notice here as well, there is almost the same format. There's also header and separated of the empty line, and there's a body of the message. Again, everything has been repeated in many different protocols in the same way. And for the verification, you can do it manually as well. If your client is reasonable enough, it will actually indicate that this message was properly signed. And if it was signed but it was badly signed, then there will be something bad. I will create you a small task associated with this lecture where you receive some text from me, and you will try to verify which part is a good part, which part has some is not necessarily the correct message, and so forth. Finally, a few last words in this lecture about the access protocols. So as I said, there's traditionally this POP3 protocol, post office protocol, and it was very basic protocol. And I mean, the protocol was, I connect to the mail server, like to my mailbox, I download everything to my local machine, and everything was deleted from the server. So that was the traditional operation, and those, by the way, not years, those it's RFC numbers, and they just look for some reason like years a little bit. But again, that protocol was quite old. It was the model, at least I was using like maybe about 10 years ago, when I had exactly one computer. I connected to the mail server, I downloaded everything, and I even disconnected from the network, so I didn't need to do anything. What we're using today is slightly different. We have like tens of different devices. So I have like 1, 2, 3, I think more than 4 devices that I usually access my email from different points. So the model of connecting to the server, downloading everything, deleting from the server is no longer the viable one. So there's several protocols. So one of the kind of the oldest ones is the IMAP protocol, where you connect to the server and you can download headers of the messages. You can organize folders in the messages, and whatever. You can do everything remotely. So you may have a copy of the messages, but you're not necessarily deleting them from the server. So effectively, the local ones is just a mirror of what you have on the server. If you want to delete message, it will be deleted locally and on the server. And if you want to keep the message, it will be just on the server and on the local machine as well. I put here the HTTP protocol. So Gmail, Hotmail, Yahoo, or any whatever other mail providers that you may have. So they give you the interface to the internal system. They also provide you the way to do kind of some manipulation of the folders. You add the filters. So those are not necessarily standard protocols. There's no really client that exists that kind of can communicate except the browser itself. But you can do all operations as you like. And the one that's missing here is Exchange protocol, but you can think is an extended version of IMAP. So the IMAP is technically only for the mail service, and Exchange has additional features as like a calendar, notifications, scheduling of, I mean, again, it's about the calendar. I think there's tons of different features that I actually didn't use that much before. And to highlight a few things about the POP3 and IMAP protocol, just to note that both of these protocols are also text-based. So they look pretty much as SMTP, as HTTP, but just using different commands. If you know some of the commands, you'll be able to kind of do the operation. If you don't know, you can simply Google like what is SMTP, or sorry, what is the POP3 commands command line, or what is the IMAP commands. POP3 is a very simple protocol. As we highlighted on the slide, there's very few things in existence. What you have to start with is username and password. Because it's retrieval protocol, these are not optional things as in SMTP, but rather first thing that have been required. And then you can list, you can retrieve, you can delete. So that's all you can do with the POP3 protocol. With IMAP, it's a little bit more complex. You can list the dictionaries. I'm actually showing this on the slide, but the protocol is quite more extensive because you can subscribe, you can list differences since specific dates. So it's kind of more extensive version of POP3 protocol, and allows you to keep effectively state on the server itself and just connect from different points, and actually sometimes even keep the connection and receive the notification about the message or message itself as soon as the email was received. And then to give you one more step before the last slide of the lecture, getting back to the push mechanism of the email. So the email is being always pushed to some point, to the point of the final server. At that stage is actually you have to pull in order to get the message. So it doesn't really, nobody, unless it's doing a setup, and that's what I'm trying to highlight. Unless you do something special, you would not gonna get this message. Nobody will nobody will push this message to your phone or try to find you specifically. So look, it's your responsibility to actually connect to the server and periodically check whether there are new messages or no new messages. So that was the traditional model. That was the model how POP3 operated. And kind of when I was using the old dial-up modem connection, like every evening we connected to dial-up server, created this dial-up connection, checked the emails. If we got received, we got excited. If we got a few messages, and we disconnected from the internet. And then kind of the next day, operation repeated. In today's environment, the process is a bit different. There are a few mechanisms that allow us to know about the messages as soon as the messages arrive. And this actually depends on the environment that we're working with. There is exchange mechanisms, so Microsoft developed this mechanism. There's IMAP way of doing business. So with IMAP, you can connect to the IMAP server. You can say, oh, I'm waiting for connection for emails on this folder, and usually it's an inbox folder. And as soon as the message arrives to the server, as soon as it arrives to the mailbox, IMAP server will kind of send you this message to you directly. This for normal computers, this normal way of doing business. It doesn't, and I think for the Android phones also uses this mechanism with the one small problem of battery life. Because with this approach, you have to keep TCP connection alive. You have to constantly even though it's not a message in between kind of IMAP protocol messages, but you still have to keep some low rate messages between you and the server to keep them alive. Apple went a slightly different direction. They created a service of notifications. So it's kind of this one centralized mechanism where they can push some notification from different applications over the single channel. So this way, only one application, like the operating system itself, has to keep alive with the whatever Apple servers, or have some connectivity with the Apple servers in order to receive any kind of notification about all other applications. And I don't know whether you flew a lot. Sometimes you can get, if you use an iPhone, you can get notification about something happening, but you cannot actually get it inside the app. And that's for that specific reason. Somehow the firewalls on a plane allow you to receive messages from Apple, but you cannot do anything beyond that. Like you cannot connect to the Gmail because everything else is effectively blocked. Okay, so that's the final part of the lecture. I hope you learned a lot about email, how email operates, how many different components we have in the system. Remember, we have a client that actually creates the message. We have a bunch of servers that deliver this message using SMTP protocol towards the final destination. And finally, there is a client or some kind of a client that receives the message using a delivery protocol, either IMAP, SMTP, POP3, or some kind of HTTP-based protocol. I hope you also got the idea that the email is not that safe. It's reasonably easy to forge emails, so that's why I have so much spam, because really there's no way to protect yourself from receiving some emails. And there's a relatively easy mechanism to actually forge email that is coming from you. And that's what you can play a little bit. You can protect yourself by using signatures, using encryption. Those possible to use, not easy to use, unfortunately, and really hard to use if you use some system like Gmail, because they don't really provide this built-in mechanism in there. There are good mechanisms being added to the protocol, especially to SMTP, to validate the sender of the email. So that's how, at least partially, we can deal with different types of spam. But still, it's not a universally accepted solution yet. Then there's still many ways of doing spam. Again, thank you for listening for this lecture, and I hope again you learned quite a bit.